So we have word count is equal to len word, which is the number of characters in the word. Then the next thing we're going to do is we're going to have a count. So can say count, that is our initializer, is going to be placed as a word count. Then the next thing I'm going to do is I'm going to create the destination string, or better still, let's just look through the list and see whether the characters and see whether we can reverse it. So we can have while count is less than or equal to 0. Here we're going to have print. Here we're going to have count, and we're going to target the index of count and then decrement the index. So have count plus equal to minus equal to 1. So let's go ahead and print this. So this is going to this is word is equal to hello, and then the word count is len word, and this is our, so this is going to string out of index. So this is word count, and this is the count. So this is word count is equal to 0, and the first one is going to target the last one, so we're going to have a -1 here. So this is going to give us the same thing. So if we want to use iteration to achieve the same thing, we can have def. Here we're going to have as our input as the string that we want to reverse. So let's call it name. It's an empty string. So we can say if len name is equal, that is what we want to achieve. So have return name. So but if it is not like this and the last character has the index of -1, so we can say name, and then we use a slicing of that is called on the function. But this time around, the function we're going to pass into the function, into the recursive function, we're going to remove the last one from it, which means we're going to use we're going to be using a slicing name, use a slicing operator. So we want to get everything all the way till just before the last character, which is -1. So this is going to have our string reversed, reverse string. Then we'll pass in the string. So here we're going to use hello, and we can go ahead and print the result. And if we print this result, it's going to give us the reversed string. Let's start by understanding what power of exponentiation means. So power of exponentiation is simply when you have 2 raised to power 3. What does it actually mean? This simply means 2/100. You may not really know what it is, but the only thing you know is that 2 raised to power 1 is equal to 2. That is the only thing you know, and you can use it as a base. Or you can have something like 2 raised to power 0 is going to give you 1. That is another thing that you know. So I think we're going to make use of this one. So even if you don't know anything, you know that whenever you raise a number to the power of 0, it is going to return that number. So that should be a recursive function, and we're going to call it def, and let me give it the name power. And for this function, we need the base and we need the exponent. The base is the main number and the power upon. If exponent is equal to 0, just return 1. That becomes our base. Then, apart from this base case scenario, what happens in other cases? And in other cases, return, then you have the base, and then you multiply that base by the recursive function, this time around ESP minus 1. So look at how it plays out. If you have 2 raised to power 3, it is the same thing as 2 multiplied by 2 raised to power 2, which is the same thing until you get to 2 raised to power 0, which is going to return 1. So this is what plays around here. So if you want to now make use of this function, you can have result is equal to, then you have power, and for this power, let's say 2 raised to power 5, and we'll print the result. 10 raised to power 2 is going to give us 100, and if we run this code, you can see we have 100. So this is how we can use. Then the next one we're going to look at is the greatest common divisor. What is greatest common? Start by understanding what highest common factor means. So highest common factor is like when you have 2 numbers, you have 4 and you have 12. What is the highest common factor or the greatest common divisor? 1, it is 4, that is the highest. We'll have 24. Or let me use something, we'll have 15. The greatest common, how do we go about determining this? So we're going to have our function. So let's call this function greatest common denominator, or let's call it greatest HCF, DFHCF. And here you are required to pass in the 2 numbers which you want to determine their greatest common divisor. So we'll have A and we'll have B, or we can have num1 and we'll have num2. So now we're going to make a little assumption. If maybe one of those numbers is equal to 0, what happens? For instance, 2 is equal to 3. What is the greatest common divisor? It should be 3. So that is what we're trying to use as our base case. So what we're going to do now is that we're going to have, if num2 is equal to 0, then return the other one, that is, which is non-0. So have, apart from this circumstance, what happens later on? I'm going to explain to you why we are using 0 as our base. So we're going to have return, then we'll call the function which is HCF. And here we're going to pass in num2. You know, if you look at the way this particular function is defined, you can see that num1 came first, parameter. Then we'll now have num1 and we'll use module. So let's go ahead and call this function and see whether it was as expected, then we'll explain what happens in the background. So if I say print HCF, here I have 3 and 6. It's expected that I get 3. We established that the base. So what is going to happen now is that this particular function is going to call itself, switching the positions. So what happens is that we're going to have 6 being our num2, and we're going to have, this time around, is that we're going to have 3 modulo 6. If we have 3 modulo 6, because 6 cannot divide 3, it means that it's going to give you 0 remainder 6. So during the next function call, what is going to happen now is that it is going to, if this is 2, so we're going to have 6 divided by 2. That is 6. We'll have num2 as 6, right? And then we have num1 as 3 modulo 6. So 3 divided by 6 is going to give you 0 remainder 6. That is the modulo. So during the next one, we're now going to have 6 modulo. I think I'm the one messing up, because what we're expected to get here is supposed to be 3. So that when you switch it around, it is going to give you 3 modulo. That is going to give you 3. And when 3 divides 3 without remainder, it is going to return 3. HCF, and we'll have 3 and 6. So what is going to happen is that it is going to have 6 here, and then perform a modulo between 3 modulo 6. So let me go ahead and print 3 modulo 6 is going to give us, it's the same thing as 1 over 3. Part 2 is 3 modulo 6 is that we're now going to have which is 3 modulo this thing, and then num2 becomes 3. So when we have 3, and we now have 3 modulo 3. So when we have 3 modulo 3, it is going to return 0. And when it returns 0, then this one becomes the num1. This is the value that it is going to return. So this is what plays up using this highest common denominator. Then again, let's look at line palindrome sequence. A palindrome sequence is a sequence that when you reverse it, it's going to still give you the same thing. For instance, when you have something like madam, if you turn it around, it will still give you what do you call it? Any name that if you twist around, it is going to give you the same thing, is considered to be a palindrome. All right. So we're going to see how we can determine whether a value, whether a sequence is palindrome. For instance, we have level. However, if you twist it around, it's still going to give you level. And one thing they have in common, if you look at it, you can see that there is M and M at the beginning and the end. We have A and we'll have A. For any given position, the values are the same. So how do we go about determining whether a value is a palindrome sequence? So how a sequence, whether a sequence is a palindrome sequence. So this is how we go about it. So let's, and we're going, then if the length of the sequence is 1, that is, it has only one item, of course, len sequence is equal to 1, then we'll return the if, then you check the first and the last items in the sequence at the last item. Do you understand? If it is equal to the value at the last item, it means we're getting towards knowing whether it is getting close to being a palindrome number. But if it is not equal to each other, it means it is not a palindrome number. So we can have if, it means that it is not a palindrome sequence. So we can say return false. What happens recursively is this. Just like we have madam like this, the first thing we do is we check, this becomes the first, this becomes the last. We check whether this and this are the same. If they are the same, we'll have this and we'll have this. So now we can see that we only have one item. If we only have one item there, it makes it a palindrome. So what we're going to do now is that we're going to have return is palindrome, calling the function. And here we're going to have S, that is sequence. And here we're targeting the second item all the way to all the way to the last item, or the last item. That is what we're targeting. This is going to give you all of them. But if you want to target the second item from the left to the second item from the right, after that, when it is calling it again, of course the sequence becomes this sequence. That way it can now determine whether the number is a palindrome or not. So this is going to give us whether determine for us whether a particular sequence is palindrome. And here I'm going to have the sequence. So let me have hello and remove this other one here and call the function. Let me have a print. Let's have result here is equal to, then here I can say print result. So this is going to give me, so this is how you determine whether a number is palindrome or not. I think this is where I'm going to be stopping. Next time we'll look at arithmetic progression and how we can perform binary search before we enter linear sequence.